Hello again. Welcome back to, I guess, my little venture playing around with ray tracing. Um, Today I'm going to demonstrate GPU ray tracing, which is an interesting area in computer graphics currently. Um, there's been a lot of technology updates, including the GTX NVIDIA cards that allow for hardware to do ray tracing. What I'm going to show you is how to make how I how a software kind of created ray tracer will work on the GPU using compute shaders. Um, as you may remember with the CPU ray tracer, which I'm going to demonstrate real quick, the it look the it's the problem with it is not that it looks good. The problem with it is that it's not really responsive. As you can see, it takes like half a second to do anything with it, and this is a huge issue. If you want to do like a game or something and use this technique, it's just not responsive at all. There's a lot of benefits with it, for example, all the shadows, reflections, the lighting looks pretty good, but it's just not responsive. In comes say GPU ray tracing, which is trying to fix it. Now, with GPU ray tracing, there are limitations. As you can see, I'm using a compute shader to do this, um, which is awesome. But the limitations with it is that you can't do recursion, so you're going to have to play around with it a little bit to get it working. And the recursion comes in when you're trying to do the reflections, so I had to kind of figure out how recursion works, the reflective recursion kind of function works from the CPU one to get it to work. And here's kind of how it looks. I have a function that has the same data, and I'm just reprocessing it. Then I recreate another array for the next reflection, and I do it over and over again for 3 times, and it produces some pretty nice reflections. Now, as you remember from the CPU version of it, I was doing 5 times, but I ran into some kind of speed issues. It's because you're redoing the scene over and over again for the reflections, so it's going to be pretty GPU intensive. If you know what I mean by that. The other issue is that you're doing I'm doing a lot of branching here, and branching is kind of a painful process for a GPU. They weren't really designed for branching, so I'm going to try to see if there's a way to optimize the branching eventually once I start doing other things with this, because eventually down the line I kind of want to make a ray tracer where I can just ray trace BVH triangles instead of using collision spheres and other collision objects. But that will come to a later date. Plus, I need to get other shapes into this thing. Other than that, it's pretty much the same. It's almost a copy and paste of the original one, but just using whatever GLS has instead of using the GLM library I've been using for math for so many years. So yeah, let's run this thing and see the difference. You're going to be pretty shocked at how smooth it runs compared to the CPU one. Look at there. It looks about the same. I did some stuff with the lighting to improve it a little bit. And there might be a little shinier, but let's try to move around. I'm pressing the right arrow key. Ooh. That's actually very interactive. Nice. Move around. The green one right there. You can look up and down and up. Pretty good reasonable speed. Very responsive. You can move around. Not bad. You can go up, look at around the scene. Not bad at all. It still needs some optimizations done with it, like because there has to be a way to like optimize like shooting rays, because what's really your bottleneck in ray tracing is how many rays you're shooting out, rather than how much geometry you have when it comes to like rasterization. So the ray count is pretty much linear, or sometimes it's going to be maybe quadratic, depending on how complex this, how many rays you need for the scene. But it's optimized to the screen width, which is pretty awesome. This means that you don't have to worry. It will call the entire scene, so you don't have to worry about scene size. You might, because scene size is logarithmic, which is pretty awesome. That means that you can have way more objects in there. The only exception is lighting, because you have to compute rays for lighting, which is kind of a hassle, but it's no big deal. Let's try to get close up on one of these spheres real quick. Let's look at all the recursive yeah, it looks really good. I'm actually genuinely impressed with this. It runs really smoothly. I can't wait to get other kind of like primitives kind of implemented. Getting some boxes in there. I might do the donut or torus too, because, well, might as well diverse the type of objects that I have, and definitely a plane so we can have a floor. I think this is it for this update. I will catch you in the next video. Y'all take care. Yeah, have a good day and stay safe out there.